Good morning, SIGCSE 2018.
Good morning.
Woo! Great to see you all. I picked up the paper, Tiffany, recently, and
You're supposed to be working.
I was walking here, and I picked up the paper and a thing. Let me read this to you. Here we go. It says, Baltimore, Maryland, February 23rd. Despite massive traffic jams at Starbucks, drenching rainstorms, and shortages of free food, water, and bathroom facilities, about 1,600 people swarmed this quiet town, camping in the woods, coding in the mud, talking, networking, and listening to wailing presentations. So it's in the paper. That's what it said.
Unbelievable.
I don't know. So very, very happy. Like 5 people got the joke. I don't know. That's working for me. That's how the front row is my good
That's
people.
why I like to teach like a couple hundred students.
That's exactly right. So let's jump on. So we're on February 23rd of our sequence of CS for All, SIGCSE 2018. This is the process of putting together the bags that you had. Is this great?
It's a good thing we don't have to wait for that in real time.
Tiffany, the bags, they're made by people.
It's us.
It's people. People. That's it. So, anyway, that's my. But joke number 2, again, 3 people. Thank you very much for the people I slipped the 22 earlier. Boy, it's our audience.
0 for 2 now.
Yeah, 0 for 2. You want to jump on some of these? That's great.
So we were just thinking, hey, we left out some of our new ideas and innovations, so we wanted to tell you about them because it's a lot of work. So we actually said, hey, let's not have everybody who's volunteering break their bags stuffing bags. Let's hire people for that. So we did that. We are videotaping the speeches in this room.
Right.
And those are going to be available through the ACM Digital Library after this. We had a web countdown timer, which was fun.
Yeah.
Except for made you have to scroll on mobile devices. You know that, right?
That's true. Yeah, that's right.
I was so impressed that there were no lines at the reception last night. Did you notice that?
Yeah, it's pretty sweet. It's pretty sweet.
Come on, you can't clap for that?
That was pretty good. And extra yummy food.
I thought that was a first.
That was the first. And extra yummy food. So that was great. That was great. And also a reminder, there's some confusion. People weren't taking advantage of the headshot booth because they think, oh, nothing's free in this world anymore.
It's totally free.
But in fact, we paid for it all completely. You get there, you just give your email address. That gets recorded by him. They then hack your account. No. Then you get any shot you want. If you want to say, look this way, with the hands, with the hat, you can do anything you want. And then that stuff is sent to you.
Just keep your clothes on.
And it's today, 10 to 5. It's in the exhibit hall hours, 10 to 5, and Saturday from 10 to noon. So again, we want to highlight some of our supporters, and we want to highlight some of their talks that are today. So let's jump right in for that. So
we have GitHub at booth 205. They have another talk today at 3:45 about outside the classroom experiences with GitHub.
Yep. Google is, again, a platinum supporter, booth 309, and today, they had a talk yesterday, and today's our talk is about incorporating machine learning into university courses.
Booth 307 is Infosys Foundation USA, and I know they're hosting PD providers at their booth, so if you want to meet some people who teach teachers how to teach computer science, you can visit there. And they have one session today at 3:45, but 3 separate talks.
Yeah, like papers, kind of 3 small 25-minute talks. Again, a platinum supporter is Intel, booth 305, and they have a talk today about the heterogeneous parallel computing future.
Microsoft is at booth 105, and today they have a Make Code presentation, so be sure to visit that.
Wonderful. Gold supporter, Codio, booth 421 and 423, and they had a talk yesterday.
IBM's at booth 211, and they have a talk today on contests.
Gold supporter is Oracle Academy, booth 214, and they had a talk yesterday.
Turing's Craft is at booth 218. I hope you noticed their awesome shirts this year. I like that orange. It matches our craft.
It does match, yeah, it's matched up.
And they have something we all love, auto grading. So I recommend that you check it out.
Another gold supporter is Vocarium, and they have a talk today on incorporating data science and teaching data science in the cloud.
Zybooks is at booth 315. So check them out.
Silver supporter, ABET, and they're at booth 208, and they have a talk on Saturday.
Code HS is at booth 118. That's one of our new supporters. We
That's
didn't
right,
have them
that's
before.
Right. That's exactly right. Yep.
They have a talk Saturday.
Yep. Another silver supporter is GradeScope, booth 522, and they have a talk on Saturday. I think they're all actually talks on Saturday from this point on.
Mimir is at booth 406, and they have another talk on Saturday.
And a bronze supporter came in, Red Hat Academy, booth 518, and they have a talk on Saturday as well. So we have an additional in-kind support. I forgot to mention the music that you're hearing as you came in. It turns out one of my best friends back in high school, he's a professional jazz musician, and I asked him if we could play his music at the conference, and he gave full permission for that, and that's Ted Perry. It's a picture of him. He plays in New York. So I wanted to add him to the in-kind support of folks, in addition to the folks we've already mentioned, Vocarium, who gives the conference badges, Turing's Craft, the volunteer T-shirts, GitHub, the bags, lanyards, volunteer party, the breaks, and Google for freshman breaks.
These jackets are from BJC.
And these bags are from BJC, that's right. So let's again, thank you to all of our supporters. Woo!
Without the supporters, you know, everyone would have to pay a couple $100 more to be here.
That's a lot more money, yes.
Yeah, so we really should be thankful, and so make sure to visit their booths. That's why they're here. They want to meet you. That's why they gave us money.
Right.
That's why they have a booth.
And they have great stuff. It's not just about that
They have
as well.
awesome
There's
stuff.
some things you can really benefit from.
Right. Don't be afraid to ask for a discount.
And don't be afraid to ask for books as well, if there folks have books in the exhibit hall as well. So people are asking about our registration numbers. There's always how are we doing live registrations? We've broken records already, and so the question is how much farther can we break? It's like Usain Bolt, how much faster can you go? So let's see if the AV works for this. Let's see with that. You heard this song? Recognize this? We did it! 1701, people! Is that amazing? Woo! Amazing, amazing. So keep it coming. We are so happy. We are so happy. This is delightful. This is delightful. It's a lot of folks in the same room. A lot of folks waiting for the dessert line, I think.
So we have a business meeting today for the SIGCSE community. That's a place where you can bring any thoughts or concerns you have to discuss with the board. They decide how the organization works and also run 3 different conferences. So get more involved, come to the business meeting at 5:10 today. It's in room 308, which is down that way.
Yep. If you have seen the T-shirts around, many people are wearing them yesterday and wearing them today. All right, go ahead. So let's, if you bought one, if you order one online, claim them by noon. Otherwise, there's we'll release all the T-shirts that aren't claimed, and we'll start selling them all locally. And the prices you'll see
Today at noon?
Today at noon.
You need to hurry.
Yeah, you gotta go. We have time. We'll give them enough time after this. It's okay. That's okay.
All right, so don't forget to use Huva. It's not Wova or Hova or what?
Like
I don't
Huva.
know. It's Huva, like who is going to the conference.
Va is go in Spanish.
Yeah, exactly.
Who's
you know,
going?
You know, like the Nova car,
Nova,
Nova.
don't go,
That's
go.
why they couldn't
Huva
sell
is
it.
like who's going.
That's right. Huva is who's going. So,
Please use... but it's okay. Just saying.
All right, please keep uploading your photos. That's what's actually showing on these projectors when you come in the rooms. It's really awesome to see what you all are doing and see everybody meeting up, and the discussions have been posted. I think there were 400 and some last night, you know. So it's really cool to see everyone interacting, so keep that up.
Yeah, wonderful. All right, well, it gives us great pleasure to introduce the next generation of folks. I'll watch this. Let's see who they are. Who might they be? So I want to introduce Manuel Perez Quiñones. By the way, it's not Manuel, it's Manuel. Just want to make sure everybody, that's also 1, 2, 3. Manuel. Okay, I don't want to hear Manuel ever again. I've heard from way too many people. Manuel. And Beth Hawthorne, the program chair of this year. Let's give them a hand, folks. Woo! Give me the clicker.
Hard to see.
I'll make a mental note to follow another Puerto Rican on stage from now on the rest of my life. That's fantastic. Thank you. Thanks, everybody. So we got a few things to tell you. The first one that we wanted to talk about is the best papers for this year. This is tough. I can't see anybody.
Not yet.
So we're going to sort of go rather quickly through this. We're just going to read the title. If you're one of the authors, please stand up and stay standing. I can't see you anyway.
Not that we can see you.
Yeah, stay standing and then hold your applause till the end because we got only a few minutes on this. So we gave awards on 3 tracks. This year, the tracks were a little bit more formal than previous years. The number of submissions went through the roof, so we wanted to sort of try to capture the quality that was coming through in the different tracks. So we have 3 Best Paper awards on each of the 3 tracks. In the CS Education Research, the Best Paper went to the persistent effect of pre-college computing experience on college CS course grades. The authors, please stand. The second, hold your applause to the end. The timer is ticking here. The CS Education Research second Best Paper went to how near peer mentoring affects middle school mentees. Stand up. The third one, enhancing security education through designing SDN security labs in cloud labs. So let's clap for the CS Education Research paper. Thank you. Next category, experience reports and tools. The best paper, Computational Thinking for All, an experience report on scaling up teaching computational thinking to all students in a major city in Sweden. Authors, please stand. Recommendations of a diversity, equity, and inclusion working group on student data for a national CS education program was the second best on this track. And the third best was Ethics Education in Context, a case study of novel ethics activities for the CS classroom. Give them a hand. Congratulations. The last category, new curricula, programs, degrees, and position papers, something else. It's a long title. It messed up all the formatting of everything we tried in the conference with that title. It's like things running off the screen. The best paper, Upward Mobility for Underrepresented Students, a model for a cohort-based bachelor's degree in computer science. Please stand. Second best paper, a model for increasing gender diversity in technology. And the third best paper, Divas, Outreach to the Natural Sciences through Image Processing. Round of applause, please. And to all the authors, we have a certificate printed in one of the best laser printers we could find. Please come at the end to the front. We'll have a picture with you and we'll give you the certificate. And if you're not here, you won't hear what I'm about to say. Come by our booth and pick up the certificate there. Thank you.
Okay, next year in SIGCSE 2019, we're excited to announce it'll be in Minneapolis, Minnesota, and we want to make sure that you all come. And Manuel and I will be the general symposium chairs, and we are excited to be working with Sarah Heckman. Come on up here, Sarah, and Jian Zhang, who couldn't be here today because she just gave birth to a lovely young daughter. So I want to congratulate Jian on the newest SIGCSE member. And our theme is going to be celebrating 50 symposiums and 49 years. So wow, that's like a one-off era, right, for us computer scientists.
No, it's a C program. We start counting in 0. Come on.
There you go. So come by booth 413 and take a look at our logos if you haven't looked at them on the Whova app. Thank you, Tiffany. So make sure you get your votes in. We're going to be announcing them tomorrow. We have our call for participation already up on the SIGCSE 2019 website that you see there. And just to let you know about Minneapolis, there's 11 miles of skyway system. So if some of you are concerned about snow, don't be concerned. You don't come to the conference and you'll be able to do everything you need to through the skyway, 11 miles.
We already requested no snow for that week, so we're all set. Either that or climate warming will just make it be tropical and you can wear flip-flops.
So we're going to show you a little preview for Minneapolis. So go ahead and run that. to seeing you in Minneapolis, and we have a few more things to tell you.
We have a session at 1 o'clock in room 323 about how to volunteer for SIGCSE. Come join us if you want to do reviews or want to be APC or want to be part of the conference organization. 1 o'clock in 323, and Sarah will be running it. We also wanted to tell you that next year is the 50th. So we want to celebrate. We want to find a way to highlight the history of the conference. I put out on Twitter this morning, and I'm going to do on Huva. Now I know how to say it. Quien goes. That's, the other version. I want to put out a call for those of you that have been around for a while. Tweet and put a message. When was your first SIGCSE? I put out on Twitter, mine was in 1990 in Washington, D.C. So go ahead and just join the conversation. When was your first SIGCSE? And just put it on Huva. And if you put it on Huva with a picture, maybe a sign that says the year, it will show up here tomorrow. So let's start celebrating the 50th. Thank you.
See you in Minneapolis.
Yes.
All right. I was told this is a smart speaker, so let me see if this works. Tell us who the next awesome presenter is going to be. Hey, that's awesome. That was pretty good. So I wanted to introduce Judy Sheard. Judy Sheard is a professor as well as being the SIGCSE vice chair, and she's going to introduce our next speaker. So thank you. Let's give a hand for Judy.
Let's go off the other way. Let's go off the other way.
Sorry?
Can we go this way?
Okay, yeah, sure. I'll leave this here.
Thanks, Dan and Tiffany. Okay, so each year SIGCSE presents 2 awards to people who have made significant contributions to computer science education. And yesterday at the First Timers Lunch we presented one of these awards, and today we're going to present the other one. So today it's my pleasure to present the award for the outstanding contribution to computer science education to Professor Tim Bell from University of Canterbury, New Zealand. Now, just a few words about Tim before he comes up. So Tim's probably best known for the CS Unplugged. He's the primary author of CS Unplugged, and that's a set of free computer science learning activities and resources that allow the teaching of computer science through games, puzzles and other activities without using a computer or programming. So these are used globally and have been responsible for thousands of students and teachers at all levels of education becoming engaged in learning computer science. As one of his nominators said, this is a step change in accessibility to computer science education to the general population. So some other comments from his nominators. Tim lives and breathes computer science education. Within New Zealand, Tim was the driving force behind the new K-12 digital technology curriculum. Someone else, other of his letters of support said, Tim's a gifted teacher. He has coordinated and delivered computer science workshops to teachers and students within New Zealand, but also globally. He's been to Europe, the US, and even Australia. And the impact, well, Australia's a lot closer for Tim than other places. So the impact of Tim's work is having significant impact on, and has had on, computing education. So Tim's work in the field of computer science education has clearly had a significant and lasting impact, and not only within New Zealand but throughout the world. Few people in our community have had similar breadth and depth of impact. So please join with me in welcome Tim to the stage. Here he is. Congratulating him on this wonderful award. Thank you.
All right.
And here's this award. Get a picture? Do you want a picture? Yeah.
Should we
Oh.
Cool.
And you ready to?
Yeah.
Talk? Okay. And now Tim's going to talk to us. So I'll hand over to Tim. Thank you.
Well, thank you. I mean, this is such a privilege, and of course, SIGCSE is kind of the mecca of computer science education. So, what a privilege to be here amongst people who are so passionate about education. And you know, when I was asked to talk to this group about CS education, it was really hard to know what to talk about because I think we're all coming from the same sort of place. But I thought it'd be good to step back and do a little bit of reflection, and so I've titled this, What's the Big Idea? Now, that can be taken two different ways because I think, you know, a lot of people who don't know much about what we do go, what's the big idea doing this in schools? You know, who needs it? But also, of course, as educators, we need to be aware, what's the big point? Because if you're like me, it's really easy to get passionate about particular areas of the subject, but I want to step back and look at that a wee bit. But for me, it'd be quite helpful just to figure out who is here. So we've obviously got, who would count themselves as a computer science educator here? Just quite a few. Okay, that's good. How many people are involved in what I would call tertiary education, university, college, that sort of thing? Okay, and how many are involved in K-12 in grade school and so on? Fantastic. And that's quite a theme is seeing these things move down towards K-12. How many people at the elementary or primary end of K-12 here? Do we have anyone? Interesting, yeah. Both of you, fantastic, welcome. Because it really is exciting that you're here because this is what I'm seeing around the world is that this whole thing has moved into high schools and now it's moving into elementary schools, into primary schools. And it's really exciting. In New Zealand, we've just adopted a curriculum from the first year of school, equivalent of grade 1 here. In America, we adopted it last December. And that started the beginning of this month, which is quite scary if you're an elementary school teacher. Yeah, and so we'll talk a wee bit about that. It's being phased in over a few years, and that's happening around the world. Australia, you might realize there's a little bit of competition between New Zealand and Australia. They actually introduced it 2 years ago, and you know, in the UK and lots of states and so on. We heard yesterday about Chicago and so on. So it's really exciting to see this happening around the world, but we do need to be aware of why we're doing it and what's going on. So I'm going to actually start with something a little bit different, and I'm going to start with something from New Zealand. This is, actually I brought one with me. It's not a real one, but I hope. This is a tui, and the tui is a native bird of New Zealand, and it's also the word tui in the Maori language, the native language of New Zealand, one of our official languages. We have 3 official languages. I can give my exam, if a student takes an exam, they can ask for it in English or Maori. Our other official language is sign language. You can ask to have that. So New Zealand Sign Language, yeah. And so the tui in Maori culture is really important, but also the word is the same as sewing or stitching or binding together. And I'd like to start, well, actually last year as part of our preparation for the new curriculum, I travelled around the country and was asked to give 10 seminars around the country to teachers and officials and so on to help understand the curriculum. It turned into 53, which is roughly 10. But because our curriculum is in both Māori and English, I had a colleague who was appointed to travel with me, and she introduced me to this, what we call a curricula, which is kind of a gathering or an encouragement or a prayer or a song. And it's something that helps us to focus on what we hear about. And this is one that I think is really significant for what we're doing. So I'll read it out to you, and we'll have a translation. And here's how it goes. And it's about the tui. Whakarongo rā, which means I listen. Whakarongo aka'a, I listen, because up high, ki te tangi i te mano, a bird flies, e e rere runga rawa e, its cry rings out. Tui, tui, tuia, sew, stitch, bind it together. Tuia runga, from above. And we think about those of us who have been doing this a long time, and we think we know what we're doing. Tuia raro, from below, those who are coming in who are just trying to figure out what's going on. Tuia roto, from within, those of us who are comfortable. And tui iwaho, from outside, those who are wondering what on earth this whole thing is even about. Tui i te here tangata, the thread of humanity, kia rongo te ao, during the day, kia rongo te po, during the night. You know those students? Tui, tui, tuia, sew, stitch, bind together. This is sometimes referred to as the thread of humanity, that we're all tied together, and we have this passion, we have this thing that we're really interested in, but I want to focus on what is binding us together, what is it that we're so passionate about. So, in case you're wondering, it is quite a long way here from Christchurch, and although this map is a bit deceptive because I came around the short way around the back. But this whole thing for me started over 25 years ago. My 5-year-old son had just started school. We started at 5 years old, and they were having parents coming along talking about what they did for a living. And I do algorithms, or I did back then. And so I thought, how do I present algorithms to a bunch of 5-year-olds? The person before me, there'd been a cop who came in a cop car, and the kids got to do the siren and stuff like that. There'd been a nurse, and she brought fake blood and bandages, and the kids had a great time. And then it was going to be a computer scientist doing algorithms. And this was the early 90s, and data projectors weren't a thing. Anyway, so I said, this is not going to work. This is going to be weird. So that's where the whole Unplugged thing started. I thought, let's just not use computers. I want to give them an experience where they can experience what I feel as a computer scientist, but obviously I'm not going to teach them to program. I'm not going to have time to do that. I had about 30 minutes with the kids, and that's where Unplugged started for me. And ever since then, I think a lot of us as educators, we like to get people to look at things differently. And so I thought I'd show you the map that's used in New Zealand. And it actually, seriously, in Maori culture, that is the way up that the map is, okay? And certainly in New Zealand, you can buy maps like that because we like to think that we're at the top of the world. And so here we are down under. I hope that you're not feeling that you're going to fall off. Yeah. But yeah, getting people to look at things differently, I think, is really important. It's one of our roles. I got an award in 1999 for this in New Zealand. It was a Science Communication Award. It's so cool. And as it happened, the day that I got the email about it, or that it was announced, we were at a party, and I just want to really acknowledge, so my wife, Judith, who is over here, she's come all the way to Baltimore to join me with this, which I appreciate, has been a wonderful support throughout this. She is a music teacher. She's very involved in education and helps to help me keep looking outwards. And so we went to a party the night that this had been announced, and people were coming up and going, "Oh, congratulations, Tim." And after a while, she said, "What for?" And I said, a communication award. I didn't get a second award that day, but let's acknowledge the people around us too who support us, because we are very passionate about what we do. But after I developed this thing in the early 90s, and very quickly, I came across a guy called Michael Fellows, who many of you may have come across, and he was doing a very similar thing in Canada, in Victoria, BC. And we ended up pooling our ideas and putting them together, and at the same time, Eric Clapton got a Grammy for his Unplugged album, and we thought, yeah, that's a good name for it. And so Mike has been very influential and developed a lot of the activities that are part of this whole Unplugged thing. And one quote that you may have come across, "Computer science is no more about computers than astronomy is about telescopes." Now, is that actually by Dijkstra? Yeah, if you Google it, you'll find Dijkstra's name all over it, but and that's an interesting exercise in how you find the origin of quotes. Mike actually wrote it way back in about 1991, and he shared it, and Dijkstra never claimed it as his own quote, but of course if you're famous and you say something, it becomes yours. But Mike was very much thinking about how do we get kids, and again, same story, he was going to his, I think, 6-year-olds class, and he just grabbed stuff that they were doing in the research lab and started doing it with 6-year-olds. If you don't tell them it's hard, they don't know. And so he had started doing this and put together this whole unplugged thing. And he was really concerned about what he referred to as the cargo cult of computing. The idea that if there's a computer there, it must be great. Okay, and I think we still kind of suffer from that. In fact, if anything, I think computers kind of inoculated schools against computer science. It's like, well, we've got computers, so we're doing computer science. I mean, one of my local schools had a computer science award for doing PowerPoint and Microsoft Office. And they go, you know, we've got it handled, you know, that's fine. And so it's been a very long journey to help people to understand what it is. And now, of course, sometimes this is misinterpreted as saying we don't want computers at all. I love programming, and I love working with computers. Well, usually love working with computers. Of course, a computer is something you go to it with a problem, and it gives you 3 in return. You know, I'm just going to try out this cool thing I saw at a booth, and it goes, well, change your password first, and then download this, but you need permission to do that, and so you need this extra thing installed, and so, and then half an hour later, you think, what was it that I was going to do? And certainly, I think a lot of the value of the unplugged thing has been when we're doing demonstrations and things like that, you can just get to the point. Oh, quick check. How many people here have actually looked at unplugged or used it, that sort of thing? Okay, great. So I will do a couple of things with it, but I just wanted to talk a little bit about you know, why we're doing that. So unplugged is a whole lot of activities that involve things with cards and strings and chalk and things like that. And it's very comfortable, we've found, for elementary school teachers, for primary school teachers, because they know those resources. They know how they work. You don't have to install them. You don't need to get permission. You don't need, you know, it's not going to crash on you and all that sort of thing. But also, when you've only got a short amount of time, it means that you can get to the point. And if we look at this whole business of computer science, I was thinking, you know, what do the public think about us? What do they think about our discipline? And I was actually in the dentist just the other day, and she said something that, you know, when she heard what I was doing, that a lot of people say, and she said, oh, kids know all about that sort of thing. Who's heard that? And yeah, and you know, you try and explain that with a mouthful of instruments and about to have painful things done to you, but if I had $1 for every time someone had said that to me, I'd probably have $30 or $40, right? So, and so we need to be able to communicate quickly. Well, there is stuff they don't know. For example, how about this? Here's another thing, but it keeps changing all the time. You must have to teach something different. And yet, I think if Turing or von Neumann looked at an iPhone or an Android today and had to program it, they go, oh, I kind of get the structure there. I kind of see what's happening. A lot of our discipline is not changing, but there is a lot more to know about. In fact, sitting the dentist, I said, well, dentistry seems to be changing all the time, but I think a dentist from 50 years ago would still kind of see the point of most of what you're doing, right? And then another thing is that, you know, when you meet people, the general public, and maybe you've had this experience at a party and people find out you're a computer scientist and they come up to you and they say, I've got a question for you. And you're going, oh, maybe they'll ask me, you know, do you think P equals MP? Or do you think you should teach recursion before iteration? Yeah. You know, those good party questions and so on. But it's typically, yeah. And of course, we know the really sad thing is, the answer is, have you tried turning it off and then on again? And so we want to be able to communicate to people who are thinking these things, and they're thinking them for good reasons. But we have this thing called computational thinking now, and you know, which in our heart we can kind of see, yeah, that seems to be a good description of what we might care about for younger kids. but maybe we're still figuring it out, and there's maybe computational participation, or maybe coding, or whatever it is, this thing that we're really interested in. And for me, especially the word coding has become a code for all these changes, and people go, oh yeah, these things in schools, they're going to introduce coding. Now, those of us who do coding know that that's possibly the least interesting part of programming and software development and that sort of stuff. But on the other hand, it's kind of taken on its own life as a word, and it just means all that cool stuff that young people can do, or something like that. And it's also got that mystery. It's the word code, and I wonder what code means, and so on. But what I want to do is we'll do something unplugged that doesn't involve coding. And Dan, I noticed that you had a newspaper before. Oh, there he is. He's got his newspaper. Excellent. And so here's a quick demonstration that I sometimes use to get people involved. I just asked someone if they've got a barcode. So you've got a barcode on that newspaper? Right. And so I haven't seen this barcode. I don't know what it is. But what I want to do is get Dan to read out the barcode. Now, I want you to read out the digits on it, all the digits, except for the last one. And then I'm going to read your mind and work out what the last one is. I'm not nervous. Okay. What's the first digit?
0.
Okay.
8. 9. 5. 0. 5. 0. 5. 0. 0. 5.
Okay, and you got one more digit there? One more digit. Okay. Right. By the way, if you're doing this, it's really important not to get them to read out the last digit, otherwise you can't read their mind. It's not very convincing. Okay. I'm going to actually give away a lot of the trick here. It's actually just computer science, but it's not magic. Well, actually, computer science kind of is magic, isn't it? Yeah. Okay. What we do is we add up the first row modulo 10. This is quite easy. 9 and 5 is 4. And kids love it, by the way, when you add up lots of numbers and you're always throwing away the tens digit. They say, why can't we do arithmetic like this all the time? It's really cool. Yeah. So 8 and 5 is 3 and 5. 8 and 5, 3. Okay. And then what we do is we multiply that number by 3. So 4 times 3 is? Excellent. Bit of constructivism there. You've worked out for yourself that 3 times 4 is 12. And again, that's so cool. Why can't we use that? Okay, so 3 times 4 is 12. So I'm going to use a 2 for that. That's a 3. 2 plus 3 is 5. And the question I'm asking is 5 plus what equals 0? 5, yeah. I mean, normally you'll get negative 5 and stuff, and then they realize that there's a trick here. So, Dan, I'm going to just read your mind. I think the last digit's 5.
It is 5.
It's 5. So on the Unplugged website, we've got all the formulas and tricks because there are 13-digit, 12-digit barcodes, 8-digit ones, and America have got these really tricky 8-digit ones that don't work very well. They're really complicated. So just you want to read up if you're going to do it, but that's about all there is to it. Now, what's the point of this? The point is that this is something that's right under people's noses that they've been using all the time, scanning barcodes and self-checkouts and things like that, and it sort of exposes something that's there that you wouldn't ever have thought of. You know, kids know all about this stuff. How many of your kids knew that that was a check digit? And so we can sort of introduce the idea that if we're going to code, there's actually a human need here, that we want accurate payment. Who checks their supermarket receipts, by the way, just out of interest, that it's accurate? Okay, so from the rest of us, thank you to the 3 of you, because we kind of trust it. And it's the same with credit card numbers and all that sort of thing. It's actually really hard to type in an incorrect number. But from a computer science point of view, we would call that a checksum, or maybe you could say it's a hash total. And then actually with hashing, like, why would you just randomly apply a formula to some numbers and end up with another one? Well, that turns out to make searching fast, and it turns out to be the basis of security and all sorts of stuff like that. And so suddenly we've opened up with a little fun activity, and the cool thing is that kids usually go, oh, I don't believe you, I'm going to try it out, and they run all around trying out different barcodes, and the teacher's going, oh, they're doing lots of arithmetic here today, I can't ever get them to do that. because that's what math actually is, isn't it? Arithmetic, not. Yeah. But then the thing that we found out fairly quickly with Unplugged, of course, is if you only do that, they go, well, that was fun, but what's that got to do with anything? And so one of the things we've been developing is the idea of plugging it in, of writing a computer program. So here's a Scratch program to do what Dan and I just did. I'm adding up the odd total and even total row, and normally I'd spend a lot of time working through this. But you can write a Scratch program that simulates what we just did, and in fact, there's the whole program. Who's feeling a bit uncomfortable with my program at the Yeah, good, excellent. Because I think a great way to learn is to show people the wrong way to do something. You know, there should be a loop in there, we could generalize that. What if there were different number of digits, all that sort of stuff. But the reality is that that Scratch program, if I actually managed to write that as a young student, I've actually persuaded that cat in Scratch to do what I just did with Dan then. And that has demonstrated that I've actually fully understood the process, because if you get anything wrong, it's not going to work out. So the Computer Science Unplugged, it's a website. We've actually just changed it in the last few weeks because it was originally designed for people like me and you to step out into classrooms and do something. And so we kind of knew what we're doing, but we needed a bit of guidance. But now that it's being used so much for schools, we've added a lot of guidance for teachers. It's actual lesson plans on a plate, adjusted for different age groups, lots of background information, lots of ways to integrate it with other areas of the curriculum, and of course, plugging it in, what you can do on a computer afterwards to follow up. So I won't go too much through things at the moment, but there's a bunch of topics that we're gradually moving over to this new format, and they match various curricula around the world. And then for each one, so for the one that we've just done now, there's a careful lesson plan explaining exactly what to do. And also one of the things that my team have just introduced, and I must say, when I was acknowledging that Mike and I sort of started this thing off, there's been a whole team of people who've been involved in doing stuff since then. They've developed this thing where you can actually customize the printouts that come with the Unplugged material to suit. So there's a cultural customization. You can choose A4 or US letter. But also, 12-digit codes are very common in North America. The rest of the world use 13-digit barcodes. So the country code for America, in case you're wondering, is 0. For New Zealand, it's 94. So we need a few more digits. And Huffman would have something to say about that, but it's you know, all these interesting things. My favorite code, by the way, country code is, get this right, 978. Anyone know what country is 978? Look it up on Wikipedia. It's called Bookland. Bookland, yeah. Every book comes from Bookland. They used to have 10-digit barcodes, and when they converted to 13, they put 978 in front of it and called it Bookland. So there's something for everyone in there, and of course you can take these as far as you want to, and sometimes we don't know when to stop, but that's all right. So then for each of these ones, there's a whole lot of programming challenges, and they range from sort of fairly straightforward ones to ones that actually require quite a bit of sophistication. At the moment, we're just getting going with that. There's some examples in Scratch. Students can see them running, but they can't see the code, and then they have to go and so you can bring them up, and it shows you what should happen, and then students can go and write the code for it. So just so you know, that there's a sister publication now for Unplugged, which is the Computer Science Field Guide, and we developed that because when computer science came into high schools in New Zealand, there were just no textbooks. There was nothing that explained the topics there. There was topics like formal languages, and if a high school teacher had never done any computer science, but they'd been teaching programming and so on, Googled formal languages, they would come up with things like how to write a sermon, or else they would find some notes from a second-year formal languages university course, which freaked people out. And so we wrote a bunch of material which introduces a lot of the ideas from computer science. And so one of the demonstrations that I quite like is one that's around digital images. So here's a digital image from yesterday, actually, and you may recognize the people in this picture. And if we zoom in, we get this very stage, but what I'm going to do is zoom in on the background a wee bit. They're pixelated just to protect the identities of those who are involved. And we see the idea of pixels, but as we zoom in, yeah, it's cool, eh? This is what makes it a digital photograph. And for a lot of the public, they go, oh yeah, I guess a digital photograph must have digits in it. Of course, most software, when you zoom in, it just blurs it and tries to do something clever with it. And so this has got RGB values, and so this curtain up here, it's got a very high value for the B and not so much for the R and the G. And people can, they usually work out that what RGB is, that it's this red, green, blue, and we've got a color mixer here, so you can reproduce the color of a pixel if you want. And so then the next question is, well, why red, green, blue? Anyone know? It's how our eyes are made, yeah. In fact, if you look into someone's eyes, not now, but at an appropriate time, and really deeply, at the back of their eyes, there are about 4.5 million cells, 4.5 megacells, that detect light, and they have pigments in them, red, green, and blue. And so we've gone now from something that was digits and RGB and stuff you see on the back of computer monitors to something that's intensely human, how our eyes are made. And that's why RGB is a big thing in the computer world. And by the way, that raises the question, not everyone has got red, green, blue sensors. Some people, 8% of males, not so good in the red, green department. And that brings us to other issues like, well, nothing very important involves distinguishing between red and green in this world, but it's and then the questions like, well, how do you get yellow by mixing red, green, and blue? Yeah, funnily enough, lots of red and green makes our eyes think that we're seeing yellow. And that's not intuitive for a lot of people, but that yellow patch that you're looking at, that's exciting the red and green sensors in your eyes, assuming that you've got a good bunch of them there. So there's, the theme here today is that it's about people. We build this geeky stuff with digits and 8-bit color and 24-bit color and that sort of thing. Really important, but it's because it matches what people can see, what people can sense, and so on. And then just to take it a bit further, I just want to introduce Arnold, the Wonder Parrot. Arnold here travels with us on all of our events and so on. He got introduced many years ago there was a magic trick called the parity trick. And yeah, Arnold the Wonder Parrot got brought in on that. It was a hilarious pun. And so he often models for things, which is quite handy. He also makes a really good noise, which the kids love. But what I have in here pre-prepared this is a photo of Arnold on a green screen. So as we go across this top row here, it's hard working with two screens here. Up here in the top left, we've got 3806.77. Do you think that's part of the green screen? And well, probably. And as we go along here, where does the green screen end? Well, round about there, the red and the green are, the red outnumbers the green, and that's probably an orangey color. That's where Arnold starts. And then people can start to see, okay, I can see that this is processing. Now, the cool thing would be to go off and write a program to remove the green screen or substitute it or something like that. But in just a few minutes, we can reveal to people, what's inside this digital thing. One other, just as an aside, fun thing I did with the class is I gave them all sheets of, this is some compressed image data, and each student was given a small part of a picture which they colored in, and then we stuck them all together. And what I'd actually done is I took a photograph of their teacher and had coded it, and it was quite exciting for them to actually see, that they'd just been given a bunch of numbers, and luckily they quite liked their teacher, and so they decoded this picture of their teacher. Okay, here's something a bit more participation. Some of you may have come across this thing called the Stroop effect, and which will not help you in this, but I'm going to try out this experiment with you. You will have seen this. I'm going to put a color on the screen. I just want everyone to call out what the color is. Okay, there's some writing. Don't worry about the writing. It's the color of the writing. So just call it out as soon as you see it. Okay, go. Oh, fast in the front row. That's red. Fantastic. Keep going. Okay, that's pretty good. Pretty good. And so, yeah, it's a basic experiment from psychology. And of course, where psychology meets computer science, well, it does in many different ways, but particularly in interfaces. And the next question is, has anyone ever used an interface that frustrates you like you just felt there? And some kids will go, no, never. And so in which case I just say, well, have your parents ever been frustrated with an interface? And have they ever said anything they shouldn't say in front of a computer and things like that? And there are so many examples, but one that exactly matches this bizarre effect is we have these magnetic locks at my office at work. And so when I'm running late, I come downstairs and there's a light on the lock that tells you if it's locked or not. So this is at the top of the door. You look up, you see this, there's a red light or there's a green light. I'm running late, I come barreling through the door. If it's green, can I go through? You would think so. Well, at least I did. It hurts, I tell you. And so it turns out that red means that it's unlocked, you can go, and green. Why would someone do it that way, apart from they like watching people slam into doors? Okay. And so we think about, well, what sort of company, so this is a digital system. Someone wrote a computer program to do this, right? And we're broadening the idea of what a computer might be anyway. But why did the programmer choose green for a locked door? Well, what sort of company do they work for? Security company. From their point of view, what's good? A locked door, yeah. And so we've got people writing a program from their own point of view rather than from the point of view of the user. And, these are kind of blatant illustrations, but it really just helps us to think about the idea that if people are writing computer programs, a lot of people say, we write computer programs for computers, but hopefully we can get them to think, actually, we write computer programs for humans, okay? And it's all connected with people. I was trying to make a hotel booking and it came up with this error message here. It says that I have to fill out some part of it and I should avoid ampersand and less than and things like that because you're always typing less than in your hotel bookings. And the error says it's an unspecified error. And by the way, I never figured this one out. I actually had to go to a different hotel. Because when you're from New Zealand, so we have 4-digit zip codes. You try putting that into a website for a start, let alone we don't have states, so there's no state to, sometimes I've just registered as Alabama because it's, whatever. But also to get students to think about their interfaces. So a lot of students will write quizzes and say Scratch, and they say things like, "You are wrong!" when you get a wrong answer. Would any teacher say that to a student? Might think it, but you don't say it. And so, just getting students to think about their own interfaces and how they are communicating to their users. As part of the field guide, we've got a bunch of videos that some of my students have made, and I thought I'd just play you a little bit of this one. It's the introduction. It's to get people thinking about interfaces.
The device you use has an interface. Some interfaces are awesome, and others range from mildly frustrating to throw your computer off a building frustrating. I wanted to see what it would be like if some humans acted like some computers. Like when computers respond too slowly.
Would you like a lemonade?
Yes, please. Yes, please. Yes. Yes, I would like a lemonade. Yes.
5 lemonades coming up.
Have you ever tried setting the time on one of these?
How many napkins would you like?
4, please.
1.
No.
2.
No.
3.
No.
4.
No. Wait. Yes.
5.
No.
6.
No.
7.
No.
8.
No.
9.
No.
10.
No.
1.
No.
2,
No.
3,
No.
4,
No.
5,
No.
6.
Or when you're not expecting your phone to do this. Say cheese.
Cheese!
Oh, I'm sorry, I'm out of storage. Oh, excuse me. Could I please have a glass of water?
Sorry, but my order pad is out of space.
Oh, it's alright, it's just there, you could just grab it.
Sorry, but my order pad is out of space.
Do you mind if I just get it?
As I said before, my order pad is out of space.
Yeah. That's Hayley. Hayley, in her final year of school, was going to be a nurse. And we just introduced a curriculum, and she went in a speech competition, and she thought, oh, she'll talk about how good computer science is before she went off to be a nurse. And she listened to her own speech and enrolled for computer science, and now she programs for the Unplugged site and does humorous videos for us. That's a part of the story, is there are so many kids that get into this by accident. And maybe you know those, and especially, that, of course, not the stereotypical ones. And we're thinking about women and people from minorities and so on, who don't see themselves as part of this. And a lot of the point is to be able to communicate to them that actually your culture, your thinking, the stuff that you care about is what we care about. And when we talk about coding, when we program, there's really different parts to it, aren't there? You have to analyze what's needed, and that involves good communication. You have to be able to design something which involves creativity. There's a skill of coding, and yes, that is a big thing. It takes a while to learn it. You have to test what you've done. That requires rigor. And there's debugging. You need to be persistent. You need to have that grit to be able to see things through. And so we end up with this idea that actually coding sounds like a really geeky technical thing, but actually it's a very human activity. And in fact, so here's a program for you. I'll just give you about 10 seconds. What does that program do? Okay. Here's a different version of the same program. And just that whole idea that when you're writing a program, you're not just communicating, they both do exactly the same thing, but one of them is communicating not just to the computer, but to the next programmer. And I think a lot of it, Alan Blackwell said, many of the skills of a professional programmer are related to a social context rather than a technical one, to get across the idea that computer programs are written for the next programmer. So this whole coding thing, it's not about computers, it's about people. It's about the interfaces, and it's about how we can help them solve problems. I'll just quickly go through another unplugged illustration because so speed is important. We've got an experiment where you can find out how quickly people find things to be instant. But in case you're wondering, almost everyone finds 1/10 of a second to be instant. So you've got 1/10 of a second for your algorithm to please someone. We've got lots of, there's some other numbers that count in there as well, but that would be perfect if we can get things within 1/10 of a second. No one will know that it wasn't instant. For searching, there's a version of it that involves ping pong balls under cups on a table, which is kind of fun, but takes a long time to set up and clean up. And there's some handouts that we have that involve hidden loot and trying to find things in treasure chests. Caitlin's here. Yeah, she's presenting at the conference as well, has done a cool video where she has 2 people searching a library for a book. One of them is using linear search. But one of my favorites is the phone book search, which is one that I think is fairly widely used, and the phone book doesn't survive very well, unfortunately. But you do a binary, well, actually, usually I just give it to someone and say, do you know how to look up a number in here? And they go, well, I think I do, but I haven't used this for a while. And then you tell them a number, 3891234, and they go, oh. I've got a friend, actually, when he was at high school some years ago, and there was a girl in his class that he really liked. And somehow he found out her phone number, but he didn't know her name. So Saturday morning, he got out the phone book. And this is a great exercise for students. How long did it take him? And of course, then we've got best case analysis. Turns out no. Worst case analysis, which is Sunday night. Average case analysis. Anyway, in case you're wondering, the answer is Sunday afternoon. Yeah. I mean, he could have asked her, but he was too shy. And everyone wants to know what happened after that, and apparently he was too shy to talk to her after that anyway, But a binary search on a phone book is really good, and often I'd say, well, the Christchurch phone book's got about 512 pages, nice round number. And of course, what you do is you go to the middle, you rip it in half, you throw half of it away, which illustrates the power of binary search. And so we get rid of 256 pages straight away. It's easy to get old phone books these days, no one wants them. And so after 9 rips, you're down to the page. That's pretty cool. That's an algorithm. But the real power of it, of course, is what if it was twice as big, if it was the Auckland phone book or the Sydney phone book, and it had 1,024 pages, and everyone, the kids will typically say, oh, that'll take twice as long, 18 rips, and then there's a sort of this minute they think about it, and of course the very first rip reduces it to the size of a Christchurch phone book, so it's only 10 rips. Now, someone decided to print all of the Wikipedia featured articles, which is a 5,000-page book. It was the biggest book I could find. And of course, you only need to rip that 13 times to find a particular article. By the way, you don't actually need to rip it, you just can open it and things, but it's more fun ripping it. And in fact, another group tried to get a grant to print all of Wikipedia, which turns out to be roughly 1 million pages. It's probably more than that now, but that's 1 mega page, and it would only take 20 rips to find something in a printed version of Wikipedia. So then we think about, well, what if you had a gigapage, right? How many rips? This is a map of Christchurch. It's about 50 kilometres, 30 miles, that this book would be. You'd probably put it on shelves in a library or something instead, but how many rips? And of course, it's only about 30. And what if we go for a terapage, which would actually stretch all the way around the world? It's about 50 megameters long, and it would only take 40 rips to look something up in that. Now, there's some slight issues with getting to the middle of the book and ripping it and all that sort of thing. But when we're working with that sort of thing, we've now introduced the idea that the most popular interface in the world, the most popular website, which is just one text box and 2 buttons, actually might have something behind it that is moderately fast. It only takes less than half a second to do a search. Oops. And so now we've got the idea, well, a computer programmer could write something with a text box and a button and a linear search, but it's not going to turn into a billion-dollar industry, is it? And so we can introduce the idea of computer science where you start typing and it predicts what you're going to type. By the way, this is really what happens if you type this in. And I know. And of course, so I clicked on the last one, and it actually turns out that computer programmers are more likely to be married than the national average for America. So in actual fact, the answer to that is that computer scientists are actually quite social, which I thought actually helps my point. But the thing is that making software, it needs to be fast, efficient, reliable, secure, usable, scalable, intelligent, and so on. So those are the kind of things that really matter. Yes, programming is really important, but we're also really concerned about making things go fast and just generally pleasing the user. Now, just thinking about particularly elementary, primary school teachers and the situation they find themselves in is there's a new curriculum coming in. And, so they are a generalist. They have to teach everything. And so these are the kind of questions they have. What is this code that people are talking about? Everyone says to use it, but I can't even install it. A kid's going to spend more time on their screen. I'm an imposter here. How long will it be till I retire? And one of the things that we've found working with teachers who are genuinely feeling like this is that there's a whole lot of things. First of all, unplugged ideas help them to get over the doorstep very quickly. And the other thing is we do quite a bit with integrated learning. This is a classic unplugged activity, the sorting network. We've got one down here. We won't do it right now, but if anyone wants to hang around afterwards and try it out, you're most welcome. And in this, kids compare values and they go left or right for the largest one and they end up sorted in order. But what we've done is things like, we'll compare the titles of books. What will happen then? What does it mean for one title to be less than another? Compare notes and music. Actually, Judith uses this. Her class can draw one of those sorting networks by memory, and they do this really regularly, comparing notes. And not just that, but, which is the lower, which is the higher value, with bells. And it's, really good oral skills. And so now you're appealing to something that the teacher actually cares about, maybe literacy, maybe numeracy, maybe music, maybe arts, and so on. So again, with Unplugged, we've connected a lot of that to integrated topics so that teachers can find things that are going to be relevant to them. One of the stories that's really motivated me as I've gone along is a lot of the young women that come along have this story. This is Yanina. She, in her own words, went through high school and hated computer science with a passion. Didn't really know what it was probably, but hated it. But her boyfriend was doing computer science, and so she sat with him in first-year classes and thought, this isn't too bad. And in fact, she enrolled, and she first came to my attention when I was giving out the class prizes, and she came first in the class for Java programming. And ended up graduating as one of our top students and ended up going to some university called Cambridge and rewrote the Java compiler as part of her PhD, and she now works for some outfit called Google. But this is a woman who got into this and absolutely loves what she does by accident. And I hear the story over and over, that they never intended to do it. And so a lot of what we're doing is that we want to try and make this, that it's not an accident. A quote, this is a very old quote, but really relevant. The greatest tragedy I know of is that so many young people never discover what they really want to do. And I think that a lot of our purpose is to help young people discover what they want to do. And for me, that doesn't mean increasing numbers. Who wants more people in their university classes, by the way? Yeah. But it means bringing in the people who didn't know that this was their thing, and actually possibly turning away some of the people who go, I thought we'd be testing games for 3 years at university or whatever. And it turns out we have to learn math and all sorts of stuff. And so just letting young people know what it is. I started with a curricula, and I'm going to finish with another saying that, from the Maori culture. It's a very old culture. It's not one where digital was a big thing, in the past years, but I think they've nailed it. And it goes like this: He aha te mea nui ki tēnei ao, which means, you ask me, what is the most important thing? Maku e ki atu. I'll tell you. He tangata, which means people. And there are two other things. He tangata, he tangata. I think the thing that drives us is that we care about our discipline, we love coding, we love algorithms, we love whatever it is our passion, but it's because it affects people, it changes people's lives. And so I hope that we can bear that in mind. Again, thank you for the opportunity to share this with you. These are the two websites that we've developed, and I just really appreciate any feedback. By the way, it's completely open source. It's all free, thanks to our sponsors. And because it's open source and it's on GitHub, if you think that, that's not quite right, you're programmers, and you can change it. And so it's there for people to use and to translate and to do whatever you want. It's got a very open license. You can even sell it if you want, which would probably be a hard job given that everyone else can get it for free. But although, just to say, people did ask because, they're charging for computer science classes maybe, or they're charging for handouts or something like that. That's fine. So there we go. Thank you very much. Thanks, Judy. Yeah. Oh. Yeah. A bit hard, but
Well, thanks, Tim. That was absolutely wonderful. I actually saw Eric Clapton on the TV last night. They had a documentary and Unplugged, and I thought, of course, he got it from Tim, but now thanks for that. Thanks for just, clarifying that provenance of that. So Tim has time for some questions, I think. We've got about 15 minutes for questions. So how do we do this? Have we got a microphone? Microphones?
Oh, there's some people over here.
Yeah.
Hi, I'm Eileen Kramer from Clemson University, and I'd worked with one of my grad students a year or two ago to do a survey of all the evaluations of Unplugged. And at the time, those that evaluated the extent to which the Unplugged activities increased excitement and interest showed results. But those that used Unplugged activities alone for conveying CS concepts typically did not have a significant result. So I noticed in your talks you talk about plugged and unplugged and kind of bridging the gap, and for the generalist teacher bringing them over the doorstep. So I'm wondering if you could talk about what are the limitations of the unplugged approach? Like for parallel and distributed computing, can we just throw together a few unplugged activities and students will figure it out? So.
It's a great question because, if you just take it and do it, then it was fun, but what difference does that make? I think one of the really important things to realize, it's not a curriculum, it's a pedagogical technique that I find teachers find it best if they just mix it up with what they're doing. So, okay, welcome class, you're all a bit rowdy, let's go outside and run around and do this activity, now let's come in and talk about it, now let's... one of the effects I have is if I'm invited to a school, I'll go in and the kids are there and they'll say, oh, you're the computer guy, so we'll put you in the computer room. Which is the worst place for the unplugged stuff, because it's like there's rubber bands between kids' fingers and the keyboards, and their model is that this guy's going to talk for 10 minutes, it's going to be boring, I'm going to ignore that, and then they're going to give me stuff to type, and I'll type it in. And so you want to, it gets them away, it gets them running, it actually gets blood to the brain, things like that, and so often teachers are using that to break things up, but then, of course, how do you then connect that? And some of it may be just, well, that was fun, now let's do something a little bit different that happens to touch on some of those ideas. Other times it will be, actually, let's make that happen on the computer. Let's get the Scratch Cat or the Python snake or whatever it is to do that. But yeah, I did a survey recently, and there's actually over 200 papers that mention Unplugged. Most of them don't really evaluate it in detail. They just say, we used it for this or we used it for that. But it feels like we're only just starting to figure out how to connect it all in.
Right, so I'd like to see more evaluations of people who start with Unplugged as the motivational part and then bridge it in the ways you've shown today.
Yeah.
Thanks.
I would too. Thank you. Yeah.
Hi, Tim. I'm Ursula Wolz. I've been to a lot of institutions right now. I'm teaching at glorious Bennington College in Vermont. Come visit. More to the point, can I please have your talk? Because I'm teaching an app development course, and my upper level juniors and seniors could really use your perspective. That's the happy news. The sad news is I'm also very proud to declare that I'm a hopeless dyslexic. And your exercise, the cognitive exercise, I couldn't do it. I could not see the color that I had to read. I was bound to do the color that I saw. And even though I'm very confident about myself as a learner, my feeling just went, oh. I felt bad because everybody else in the room was going red, green, yellow, and I was going white, blue, pink. Okay?
Yeah.
And I think that's something we don't do enough in computer science classes, especially when we're talking about diversity.
Yeah.
Okay, we don't understand that there are kids who get it because of whatever kinesthetic things they did in the past. And we don't understand that they're sitting there going, I can't do this and I must be stupid.
Yeah.
And the reason I applaud you is we have been using your activities forever with college students, and they're marvelous. And I'd like your comment on what just happened to me and that, oh my God, I can't do this.
Yeah. So I mean, one of the things is for us, it's quite good to get out of your comfort zone because we're making a lot of teachers get out of their comfort zone. And the other thing, of course, is that with the diversity of students we have, there's so many issues. For example, this works terribly in foreign countries because they can see the colors easily and the word's not a distractor. By the way, another hint, if you ever have to do it again, take your glasses off if you've got glasses. Yeah, or squint your eyes. It's actually easier if you have some impairment, which is bizarre. But yeah, we're asking for things like, turn left and right, or bigger and smaller, and so on. And yeah, teachers are going to have to be very aware of their own cultural environment. Some of the activities, so there's a famous peanut butter and jelly exercise where you make a sandwich and that. In Maori culture, using food for anything other than eating is really offensive. And if you did that in a class with Maori kids there, it would be like someone just went and put their feet on grandma's table. It's like, oh, this is terrible. And so there's so many different situations that you can be caught out in. And I could tell you a lot of stories where I've just stepped on the wrong toes, by doing, I was in an inner city school once and I had some cards that were red and white. And it turned out that you don't use the color red in that school, And so, yeah, there's so much to think about and adjust it. It's not, here it is, do it. It's here it is, adapt it for your situation. But thank you for those comments, yeah.
Yeah, good morning. Joseph Caro Miranda from the University of Puerto Rico. And first of all, I really want to appreciate the work you've done with CS Unplugged. Particularly, I want you to leave with a good story, which is the fact that in Puerto Rico, we were hit by a hurricane. Most of that island is still without electricity. Yet we've had good conversations within the Department of Education, particularly to catalyze the CS for All initiative in Puerto Rico. And CS Unplugged was a huge catalyst in the sense that it became an alternative as to how can we begin with CS for All classes and initiatives. And so over 15% of the schools, because of the lack of electricity, jumped on CS Unplugged as a way to continue teaching classes. Just wanted to share that.
And by the way, if you're giving a presentation, there's so much that can go wrong. There's nothing like being the computer person and the PowerPoint system just won't work for you. It's great. I've got my backup down here on the floor and it's not going to crash. Yeah, it's cool.
Thanks, Tim, for a really inspiring talk. I was actually crying at the end because I think that what you're doing is really meaningful to all of us. And I wanted to say thank you because, sorry. I've worked a long time trying to get more people into computer science, and a lot of times we have people that come in for a little bit because they think this might be for me, and it doesn't take long before they start thinking maybe it's not for me. And we've been using CS Unplugged in the STARS Computing Corps, which is an alliance for getting computer science students to go out and bring more people into computer science. And it's a way that we've used to get freshmen to go reach out to middle school students, high school students, and tell them about computer science. And just like you said with your nursing student, when they go out to other schools and say how cool computer science is, they go back and they're like, well, I can't change my major now. But it also just lets them get some efficacy and take some leadership. And I think it means a lot that you've made these tools. And I think all of us who've used them should maybe stand up so we can see how many people who have used your tools in here.
Ah. Whoa. Thank you.
So I think we've got time for one more question.
Hi, I'm Krish Narayanan from Eastern Michigan University. Thanks, Tim, for CS Unplugged. My involvement with K-12 actually started with CS Unplugged, so I feel really thankful to you. Here's one of the things that I've been grappling with. So when I teach kids algorithms, which is the hardest part to teach, I can teach Scratch to kids and they're all great. But when you start teaching algorithms, it's hard for them to really get the concept. So I would use CS Unplugged, and they would be happy. They would go home and be happy. But then the next day, the parents would come and ask me, looks like you didn't teach them computer science or programming. Looks like they just had fun. Yeah. So how do you convince parents that their kids are actually learning? And it's not just programming like Python and Java, but it's more of an understanding and more of computational thinking. How do you convince parents that we are on the right track?
That's a great question. Because as these things, I mean, we're in the middle of a revolution. This is a subject that's never been taught in grade school before around the world, and it's being introduced. And so parents were never taught it, very few, and so, our challenge is how do we get parents enthusiastic? I'm sorry, I don't have an easy answer. How do we get officials enthusiastic? Because the other thing is that, as you're pointing out, if you go to officials, they go, oh, computer science, yeah, that's important. We'll buy a computer for every school. Done. And then how do you get the teachers enthusiastic? The only people who are easy to deal with are the kids, because you do something cool and they just go, oh, that's cool. And I think actually, Unplugged isn't, well, if you can get parents together, and I've been to parents' meetings and things like that, doing some of this, but then always connecting it. This is the kind of understanding they have. They will need to code it to make it work at some point. And one of the points, of course, is that we're kind of trying to sell coding as both easy and really hard. And that's kind of a weird thing too. So with something like Hour of Code, you can be a coder after an hour, but actually probably another 9,999 hours would help. And it's a difficult, I see the same in music. And you could teach a kid to play Twinkle Twinkle Little Star on the piano, probably in an hour, and you'd say, wow, you're a pianist, that's fantastic. But if they did that for the next 20 years, then you would stop calling them a pianist, and so it's like any other skill. I think society will gradually get to understand what this whole thing is about, but we are at a transition point where we do need to be able to communicate it, and we need to be very clever about it. Some of the organizations represented here are doing a wonderful job in the media, so the media is very important. Half the reason we have problems is the way media portrays our discipline. And so, if we can counteract that, but you're dealing with a huge change of attitude and so on. The other thing is to meet parents with what they care about, because sometimes they care about jobs for their kids. Some parents, they want one of each, a doctor, a lawyer, and an accountant. And to help them get to the point of realizing that actually, a software engineer would be actually quite good is one of the challenges as well. And it's going to take us a while to get there, but it's going to be an effort for everyone. It's going to be all the different kind of things that we do that we need to reach people with. Yeah. I think in the end, though, if you can get across that message, it's actually about people, because a lot of this is that they put in a box. Yeah, that's the weird people who like coding. If we can get it out of that box and it's no, those weird people, there's a few of them, but there's actually people who care about people and want to code and make things different. If we can get that message out, then that will help as well. And especially if you end up, I had a student turn up, she'd done 4 years of medical school. And she said, every year someone told me that it was going to be better next year. And I don't like it. She's top in science. Can I do software engineering? And she switched over and is top in software engineering. And she ended up writing software for stroke rehabilitation. So instead of helping a few hundred people as a doctor, she's helped thousands of people by writing the software, medical software. Those kind of stories, I think, will help to see that it's not just a weird thing that we do. It's actually something that's going to affect society. Yeah.
Okay. Let's give him another hand. So if you want to come talk to Tim as well, he'll be available after the talk to visit. And if the folks who won the Best Paper Awards can come to the front so we can get some photographs of them. The session's open at 10, so you have some time to stretch and hit the restroom before the exhibit hall's open. So head over there when you're ready and come on up if you want to see Tim and if you want a Best Paper Award. Thanks so much, folks. Enjoy SIGCSE 2018.